So on May 19th, 2026, there was this single post on X that just completely shifted the balance of power in Silicon
Oh,
Valley.
absolutely. It was massive.
Right. And it wasn't a product launch or, some new benchmarking metric that nobody understands. It was just an employment update.
Yeah, just a simple life update post.
Exactly. Andrej Karpathy, who is, objectively one of the most influential minds in the history of artificial intelligence, he announced he was leaving his own educational startup to join Anthropic.
Which caught a lot of people off guard.
Totally. And he wasn't just taking a board seat, he was going right back into the engine room. Specifically, he was joining Anthropic's pre-training team. So today we are doing a deep dive, and we've got our hands on this really extensive research report that dissects this exact move.
And it is a fascinating report.
It really is. And our mission today is to uncover why this isn't just, another tech executive jumping ship for a bigger equity package or whatever. This hire is essentially the starting gun for the era of AI systems that literally build themselves.
I mean, it's the ultimate directional signal, right? If you want to know where the frontier of this technology is heading, you don't just look at the PR. You follow the people who actually write the code that shapes the frontier.
People in the trenches.
Exactly. And Karpathy's move forces us to look at this massive convergence happening right now. We're talking hyperscale compute hoarding, synthetic data generation, and this escalating, really high-stakes cybersecurity arms race.
So for you listening right now, whether you are actively building with AI or maybe using it to accelerate your own engineering workflows, or even if you're just trying to navigate a tech landscape that feels like it's moving at light speed, this deep dive is your map.
It really outlines exactly what's coming next.
Yeah, because Karpathy's new mandate at Anthropic is basically the X that marks the exact spot where the next massive leap in capability is going to happen.
Right.
So let's jump right into the fallout from that May 19th announcement. The tech press obviously exploded. Reuters, TechCrunch, the Wall Street Journal, they all scrambled to cover it.
Naturally. It's a huge story.
But the way it was covered revealed a really fascinating historical quirk, which the report points out. A lot of the headlines from reputable outlets called him an OpenAI co-founder. But the intelligence report we're looking at pushes back incredibly hard on that specific terminology.
It does, yeah. And for a very good reason, actually. I mean, precision in historical record-keeping matters immensely, especially when we were talking about frontier labs, where the origin narratives carry so much cultural and strategic weight.
Right, the lore matters.
It does. If you go back to the primary source, which is OpenAI's original Introducing OpenAI launch post from December 11th, 2015, the organizational hierarchy is meticulously documented there.
I think I read that it lists Ilya Sutskever as the research director, right?
Yes, and it lists Greg Brockman as CTO. And Sam Altman and Elon Musk are named as the co-chairs.
Okay, and then Karpathy is listed alongside a few others simply as one of the group's, quote, other founding members. I actually even checked his personal website before we started recording, and he uses that exact phrase, founding member. He explicitly avoids calling himself a co-founder.
Which is such a crucial distinction.
Yeah.
I mean, the media tends to flatten history to make punchy headlines, right? But calling him a co-founder implies he was organizing the corporate structure, or securing the initial capital, or defining the legal charter.
Sitting in boardroom meetings with lawyers.
Right, exactly. That wasn't his role at all.
Okay, let's unpack this, because my read on this distinction highlights exactly why Anthropic wants him now. It might seem like semantics, but it's like calling someone the lead singer of a band versus the founding bassist.
Oh, that's a great analogy.
Right. Both are crucial to the sound, but precision helps us understand his actual historical role. Being a co-founder is a corporate designation. Being a founding member, at least in the context of a 2015 AI lab, means you were the one actually in the weeds writing the initial algorithms.
You were the one staring at the terminal.
Exactly. You were laying down the technical foundation when the whole thing was just this super risky experiment. He wasn't in the boardroom, he was in the terminal.
That's a highly accurate way to frame it. He is, at his core, a relentless operator. And that operator mentality is exactly what Anthropic needs at this specific layer of their development stack right now.
Which brings us to his background.
Right. To really grasp the gravity of him stepping into Anthropic's pre-training team, we have to trace the architectural lineage of his career. Because his pedigree isn't just, impressive, it's structurally unique in a way that perfectly mirrors the evolution of the AI industry itself.
Yeah, let's trace that lineage, because reading this report, it feels less like a standard resume and more like a roadmap of literally every major bottleneck the industry has faced over the last decade.
It really does.
So he does his undergrad at the University of Toronto, heavily influenced by Jeff Hinton, then a master's at the University of British Columbia. But things get really interesting when he lands at Stanford for his PhD under Fei-Fei Li.
Right, and Fei-Fei Li's lab was the absolute epicenter of computer vision at the time.
Oh, for sure.
And if you look at Karpathy's publication record from those Stanford years, he wasn't just working on, like, isolated visual recognition. He was working at the interface of modalities.
What does that mean exactly?
Well, in 2014, he published work on bidirectional image sentence mapping. And then in 2015, he focused on deep visual semantic alignments for generating image descriptions.
So long before we had models that could, seamlessly look at a photo and write a poem about it, he was figuring out how to map the mathematical representation of a pixel to the mathematical representation of a word.
Precisely. He was building the bridge between seeing and describing. And in 2016, he published a landmark paper called DenseCap.
Oh, right. The report mentions DenseCap.
Yeah, it focused on dense multimodal representation learning.
Okay, let me pause you right there, because dense multimodal representation learning is one of those phrases that sounds amazing in a slide deck, but can be a bit opaque for the rest of us.
Fair enough. It is a mouthful.
So my understanding is that earlier computer vision models could maybe look at a picture of a kitchen and just output the word kitchen. Or maybe dog, if there's a prominent dog in the frame.
Right, very basic object labeling.
But DenseCap was about identifying multiple specific regions in an image and generating a rich, natural language description for every single region, like the brown dog sitting under the wooden table. Am I capturing the leap in capability there?
You've hit on the exact mechanism, yeah.
Yeah.
Before DenseCap, object detection and image captioning were often treated as completely separate, distinct tasks.
Oh, I see.
You either drew a bounding box around an object or you wrote a generic sentence about the whole image. What Karpathy and his co-authors did was integrate those tasks into a single cohesive neural network architecture.
So it does both at the same time.
Exactly. The model learns to jointly localize regions of interest and describe them in natural language. This is literally the bedrock of what we now consider native multimodal intelligence. It's the ability to not just see, but to articulate the relationships between objects in a spatial environment.
And he didn't stop there. The report highlights a 2017 paper he co-authored called World of Bits. And looking back from our current vantage point in 2026, this paper feels almost prophetic.
World of Bits was a massive conceptual leap. I mean, huge. The idea was to move away from training AI in these constrained, custom-built simulated environments and instead train reinforcement learning agents to operate directly on the internet.
Wait, really? Like using an actual web browser?
Yes. They framed the web browser itself as the environment, so the AI had to learn to navigate DOM elements, click buttons, and fill out forms just like a human would.
Which is exactly what the entire industry is obsessed with right now. Agentic workflows. Getting an AI to actually do things on a computer rather than just generating text in a chat window.
Right, and he was mapping out the architecture for autonomous web agents almost a decade ago.
That's wild.
Yeah.
But here is where his trajectory diverges from almost every other elite academic researcher of his generation.
Yeah, it takes a sharp turn.
Because in 2017, right after his first stint as a founding member at OpenAI, he leaves the pure research environment completely and goes to Tesla to become the director of AI.
And this is the era that I think truly defines his operational mindset. From 2017 to 2022, he isn't just publishing papers about theoretical agents navigating theoretical web pages. He is responsible for autopilot.
Which is terrifying when you think about it.
It is. He is tasked with taking these sprawling, unpredictable neural networks and shoving them into 2-ton vehicles, moving at 70 miles an hour in the physical world.
And that transition introduces a level of constraint that has to fundamentally rewire how an engineer approaches AI.
Oh, completely. Because in an academic lab or even an early-stage frontier lab, if your model hallucinates a weird answer 1% of the time, it's just an interesting edge case to write a paper about.
Yeah, you just say it needs more research.
Exactly. But at Tesla, if your vision model hallucinates a phantom obstacle or fails to see a semi-truck 1% of the time, the product is catastrophically unviable.
Yeah, the tolerance for error drops to absolute zero. Lives are literally on the line.
Right. And to solve that, Karpathy had to build what he famously called the data engine.
The data engine. Let's dig into that.
So he realized that tweaking the model architecture was no longer the primary lever for improvement, The bottleneck was the data itself.
Like the actual images coming from the car.
Yes. He had to build massive, highly optimized data labeling pipelines. He had to figure out how to source specific, weird edge case examples from a fleet of millions of cars, label them perfectly, and feed them back into the training loop.
So if the car gets confused by, I don't know, stop sign covered in snow, they have to go find 10,000 images of snowy stop signs.
Exactly. And to do that, he was running hyperscale, distributed training clusters under brutal, real-world deployment pressures.
So he masters the translation of vision to language at Stanford. He masters the deployment of hyperscale, zero-tolerance data pipelines at Tesla. Then, early in 2023, he goes back to OpenAI.
Right, his second stint.
And the report notes he returned specifically to build a new team focused on mid-training and synthetic data generation. We are going to unpack the mechanics of mid-training shortly because it is the entire key to his new role. But he stays at OpenAI for about a year, leaves in early 2024, and in July 2024, he launches Eureka Labs.
Eureka Labs, yeah, an AI-native education platform.
Okay, this is the part that I genuinely struggle to reconcile.
Why is that?
Because you have this guy who is arguably one of the top 5 applied AI operators on the planet. He knows how to scale compute clusters. He knows how to deploy real-world agents. He understands the deepest layers of synthetic data generation.
Yeah, his resume is unmatched.
And he steps away from the bleeding edge of the AI arms race to build a digital school. And then, less than 2 years later, he abandons the school to go back into the deepest, darkest trenches of Anthropic's pre-training team.
It does seem abrupt.
It feels like a massive whiplash. So, what does this all mean for his new job? If he just stepped away to launch an education platform, isn't returning to the hardcore R&D grind a massive pivot, how does teaching connect to building the base models?
Well, it only looks like whiplash if you maintain the traditional boundary between teaching a human and programming a computer.
Oh, interesting.
Karpathy erased that boundary years ago. He has always been deeply embedded in developer pedagogy. Even while he was a PhD student, he architected and was the primary instructor for Stanford's CS231N course.
Right, that was their first deep learning course for computer vision, right?
Yes, and it exploded in popularity.
And his open source work is legendary too, things like NanoGPT, where he basically boiled down the underlying architecture of modern language models into a handful of files that any competent developer could read and understand.
He loves teaching. But the philosophical bridge here is an essay he published back in 2017 called Software 2.0.
Software 2.0.
Right. In it, he argued that neural networks represent a fundamental paradigm shift in how we create software.
Yes.
In Software 1.0, a human programmer writes explicit instructions in a language like C++ or Python. You tell the computer exactly what logic to follow, line by line.
Like a recipe.
Exactly. But in Software 2.0, the neural network's weights are the program, and you don't write weights by hand. You compile them by feeding the network data and optimizing an objective function.
So if you are no longer typing lines of explicit logic, your job shifts from being a traditional programmer to being a curator of data. You are essentially designing a curriculum for the AI.
Precisely. You are a teacher. And when you look at his new mandate at Anthropic, the connection to teaching becomes incredibly literal.
Okay, let's dive into that mandate.
He joined the pre-training team, reporting to Nick Joseph, TechCrunch, and actually Nick Joseph himself confirmed the specific mandate. Karpathy is building a team to use Claude to accelerate pre-training research itself.
Okay, let's spend some time on this because it's the crux of the whole report. Using Claude to accelerate pre-training. That sounds like a neat operational efficiency, like using a calculator to do your accounting faster.
It sounds simple on the surface.
But the report implies something much more profound. It's not just using AI as a tool, it's a meta-research loop.
Yes, and to understand the magnitude of this, we have to look at what pre-training actually entails at a place like Anthropic in 2026.
It's not just uploading some PDFs.
No, not at all. Pre-training is an excruciatingly complex engineering bottleneck. The pre-training team designs these massive distributed architectures. They develop the optimizers. They curate and filter terabytes of raw data.
And they write the custom code required to keep thousands of GPUs running in perfect synchronization without failing, right?
Exactly. And Anthropic's approach to this layer has evolved significantly. The report details how they're actively blurring the traditional lines of model development.
Right, because in the past, you baked the cake, and that was pre-training. Then you put the frosting on, which was fine-tuning or RLHF reinforcement, learning from human feedback just to make the model act safe and polite.
The frosting analogy is perfect.
But Anthropic is actively moving the safety and capability shaping much earlier in the pipeline now.
Yes. Through techniques like pre-training data filtering and what they call model spec mid-training.
Okay, let's break down model spec mid-training, because if I'm reading this correctly, it's not just fine-tuning at the end. They're altering the core gradient updates before the model completely solidifies.
They're intervening while the concrete is still wet, essentially.
Right. They are trying to bake the alignment in so deeply that it generalizes across entirely novel situations, rather than just teaching the model a set of polite, canned responses.
That's a very sharp way to frame it. Think of standard RLHF, the frosting, as teaching a model a behavioral heuristic, like when someone asks for instructions on building a bomb, say no.
Simple enough.
Right. The problem is, as models get smarter, they can be tricked into bypassing those heuristics. They find loopholes. So mid-training aims to instill a deeper structural understanding of why certain behaviors are desirable or harmful.
How do they even do that?
Anthropic does this by generating massive amounts of synthetic documents. These are essentially AI-written textbooks, dialogue trees, and theoretical scenarios that deeply explore the nuances of their model specification document.
So they use an existing, highly capable model to write millions of pages of synthetic data that perfectly demonstrate complex reasoning, ethical trade-offs, and advanced coding logic. And they inject that synthetic data directly into the later stages of the pre-training run.
Exactly. And think about who was leading the team working on mid-training and synthetic data generation at OpenAI right before they launched their GPT-4 and GPT-5 class models.
Andrej Karpathy.
Andrej Karpathy. He has intimate, hands-on experience at the exact scene where Anthropic believes the battle for the next generation of AI will be won.
So when the mandate is using Claude to accelerate pre-training, we aren't just talking about having Claude write some boilerplate Python scripts for the engineering team.
No, much bigger than that.
We are talking about a recursive acceleration loop. Here's where it gets really interesting. It's like a master toolmaker realizing the best way to build a better wrench isn't with a hammer, but by building a factory where wrenches design themselves.
That is exactly what it is. Claude is proposing the architectural experiments. Claude is analyzing the results of those training runs. Claude is generating the synthetic data required to make the next version of Claude smarter.
Wow.
It is the literal realization of an AI designing its successor. And Karpathy is the human architect overseeing that recursive loop. He is building that self-designing factory.
But creating a factory like that running recursive meta-research loops using frontier models is not a software problem anymore, is it? It is a physics problem.
Absolutely.
You cannot run self-improving AI on a standard cloud cluster. You need an entirely different scale of infrastructure. Which brings us to the most staggering section of this intelligence report, the hyperscale battlefield.
The numbers are just wild.
Because the numbers attached to Anthropic in early 2026 are honestly difficult to comprehend. We aren't just talking about a software app anymore. These are national security adjacent platform companies hoarding gigawatts of power.
Right. The capitalization and infrastructure requirements have separated the AI industry from the rest of the software world entirely. We are no longer talking about startups raising $50 million to buy some servers in Iraq.
No.
We are talking about nation-state level industrial mobilization.
Let me lay out the financial reality of Anthropic as detailed in the report. As of early 2026, they closed a Series G funding round that gave them a post-money valuation of $380 billion.
$380 billion.
Let that sink in. But more importantly, look at the revenue velocity. The report notes their run rate revenue jumped from $14 billion in February to over $30 billion by April of 2026.
A jump of $16 billion in annualized run rate over roughly 8 weeks.
It's absurd.
It implies massive systemic enterprise adoption at a scale that eclipses the fastest-growing SaaS companies in history. But the capital is merely the instrument. The actual weapon they are buying with that capital is compute.
Let's talk about the compute, because this is where the physics problem comes in. The report states that Amazon remains Anthropic's primary cloud partner, and they have secured up to 5 gigawatts of Amazon-related compute capacity.
We really need to pause on that figure because gigawatt is a term mostly used by utility grid operators, not software engineers.
Yeah, I don't think people realize how much power that is.
A typical, massive, traditional data center might consume maybe 50 to 100 megawatts of power. 1 gigawatt is 1,000
Oh,
megawatts. So
you're right.
it is roughly the power output of a large commercial nuclear reactor. So Anthropic has secured access to the equivalent of 5 nuclear reactors worth of power solely dedicated to running and training their models.
And that is just from Amazon. The report also details multiple gigawatts of next-generation TPU capacity secured through Google and Broadcom. They have a strategic arrangement utilizing $30 billion of Azure capacity through a complex deal with Microsoft and NVIDIA. And on top of all that, they have an agreement to utilize all the compute capacity at SpaceX's Colossus One data center.
The sheer logistical complexity of this infrastructure is terrifying. I mean, you have to consider the supply chains required to manufacture hundreds of thousands of specialized accelerators.
The silicon alone is a bottleneck.
Right. You have to consider the cooling requirements, the power grid interconnects, the networking latency between clusters that span physical geography. It's an engineering marvel just to turn it on.
But here's what I find fascinating about this compute arms race in relation to Karpathy's hire. You don't hoard 5 gigawatts of power unless you have a bottleneck you are trying to break.
That is the core strategic insight here. Historically, the bottleneck in AI research was talent.
Right, not enough smart people.
Well, you had brilliant researchers sitting around waiting for their experiments to finish compiling unlimited hardware. If you have a breakthrough idea, but it takes 3 months to run the training job, your iteration cycle is agonizingly slow.
You're just staring at a progress bar.
Exactly. Anthropic's compute hoarding is an attempt to invert that bottleneck entirely.
They want infinite hardware so the human minds are never waiting.
Precisely. If you have 5 gigawatts of compute, talent is only fully utilized if they can design experiments fast enough to keep the servers hot.
Oh, wow.
Karpathy isn't arriving to save a struggling company. He is arriving exactly at the moment when Anthropic has enough raw compute to ensure that a massive, automated, Claude-driven meta research loop can run continuously without ever hitting a hardware ceiling.
They built the ultimate engine, and now they need the maestro to conduct it.
Exactly.
But we have to look at the other side of this battlefield. OpenAI isn't exactly sitting still, right? The report outlines their countermaneuvers, and they are just as aggressive. In March 2026, OpenAI announced a $122 billion raise.
Yeah, the Stargate infrastructure project.
Right. They are actively building out Stargate in partnership with Oracle and SoftBank.
And their product velocity remains formidable, too. The report notes they have pushed out GPT 5.3 codecs, GPT 5.4, and are previewing GPT 5.5. From a purely capitalized, resource-heavy standpoint, OpenAI is a juggernaut.
For sure.
Losing Karpathy isn't going to break them financially or technically.
It's not an existential threat to their survival today, but my read of the report is that it exposes a chronic vulnerability for them. It's a narrative vulnerability. Karpathy's departure is part of a larger pattern of visible talent redistribution.
Yes. The list of departures from OpenAI over the preceding 2 years is highly conspicuous.
Pretty long list.
John Schulman left for Anthropic in August 2024. Ilya Sutskever, the man who is listed as the research director on the founding document, left in 2024. Mira Murati, the CTO, departed in September 2024. And now Karpathy has left for a second time.
When you have that much elite talent bleeding out, even if you are shipping incredible products, it allows rivals to craft a very compelling narrative. Anthropic can position itself to the developer community and to investors as the superior environment for hardcore, unencumbered technical research.
And in an industry where talent is still relatively scarce at the very frontier, perception creates reality. If the best engineers believe Anthropic is the place to be, that is where they will go.
So we have this landscape of infinite capital, gigawatts of power, and elite talent converging. The obvious question is, what is the actual product they are racing to build? What requires this level of mobilization?
Right.
That brings us to Karpathy's public philosophy, which the report details heavily, specifically the concept of Software 3.0 and the agentic future.
Karpathy's public statements over the last year have aligned perfectly with Anthropic's product roadmap. In his 2025 LLM Year in Review, he explicitly praised an Anthropic product. He called Claude Code the first convincing demonstration of a usable LLM agent.
And he highlighted a very specific architectural choice Anthropic made there. Instead of building a cloud-based container where the AI operates in isolation, Anthropic focused on local computer-resident agents.
Exactly.
They built a tool that developers could drop directly into their existing local workflows.
Which is the fundamental premise of his vision for Software 3.0, a concept he expanded on heavily at the Sequoia Ascent Conference in early 2026.
Okay, let's unpack Software 3.0, because if Software 1.0 is a human writing Python and Software 2.0 is a neural network optimizing its weights based on a data set, what is 3.0? It sounds like we are moving further and further away from the actual machine logic.
We are. In Software 3.0, the artifacts of the program are entirely different. Karpathy argues that the prompts you write, the tools you grant the AI access to, the memory you allow it to retain, and the context window itself, those elements are the program.
So you're not coding anymore.
Right. You are no longer writing logic or even curating datasets. You are configuring an environment and a set of behavioral instructions for an autonomous agent to execute on your behalf.
He actually popularized the term vibe coding in early 2025 to describe this. I love the casual nature of that term, but it describes a deeply complex shift.
It does.
If you're using Claude to help you code, Karpathy is the guy shaping the language and intuition of that very workflow. He's not just building the model, he's telling us how to use it. Instead of painstakingly managing the syntax of every function, you are acting almost like an art director.
That's a good way to put it.
You are giving the AI the vibe or the high-level intent of what you want built, you let it generate the structure, and then you review and steer its outputs.
But for vibe coding to actually work in a professional environment, the underlying model has to possess incredible reasoning capabilities. And Karpathy laid out a very concrete framework for how models achieve these capability spikes.
What's our framework?
He argues it comes down to a combination of training attention, data coverage, economic value, and most importantly, verifiability.
Let's focus on that concept of verifiability, because the report leans heavily into it, and I think it is the key to understanding why coding is the ultimate battleground right now.
It is the absolute core of it.
Because if I ask a language model to write a sonnet about a sunset, how does it know if it did a good job?
It doesn't. Evaluating a poem is purely subjective. It's like an art class.
Hmm.
A human reader might give it a 10 out of 10, another might give it a 4. The feedback loop is noisy, it's slow, and heavily dependent on human preference.
Right. But if I ask a language model to write a Python script that sorts a database, it's a completely different scenario. It's a math test.
Exactly. It is objectively verifiable. The code either compiles or it throws a syntax error. It either passes the unit tests or it fails.
There's no middle ground.
Right, because the environment itself provides immediate objective feedback. The AI can run rapid, automated learning loops. It can write a script, run it, see the error, rewrite the script, and run it again without ever needing a human to intervene.
And when you combine that mathematically verifiable feedback loop with massive economic value, because, let's face it, a system that can autonomously write enterprise software is worth hundreds of billions of dollars, you get a situation where the frontier labs throw all of their compute and training attention at coding.
Which brings us directly back to Anthropic's commercial wedge. The report notes that their current lineup, Claude Opus 4.6, Sonnet 4.6, and specifically the highly engineered Opus 4.7, are explicitly targeted at agentic developer workflows and complex, long-context software engineering tasks.
That's their main target audience.
Yes. Anthropic's core thesis is that software engineers are the fastest adopters of AI, and that dominating the coding workflow is the beachhead for dominating the entire enterprise market.
The alignment is almost terrifyingly perfect. You have Anthropic building the ultimate agentic coding tools, and you hire the exact guy who has been shaping the philosophy of Software 3.0 and developer pedagogy for the last decade to help automate the creation of those very tools.
It is a closed loop of hyper-optimization. But that closed loop introduces massive friction.
Yes, because giving AI models the autonomy to write code and act as agents in a local computer environment introduces massive friction and risk, which transitions us into the darker, more volatile sections of this intelligence report.
It gets very complicated here.
We cannot talk about autonomous coding agents without discussing the dual-use nature of this technology, because the exact same capabilities that make an AI a phenomenal software engineer inherently make it a terrifyingly capable hacker.
The underlying logic is identical. If a model has the deep structural understanding required to look at a massive million-line code base, understand the architecture, and write a script to optimize it.
It can find the flaws.
Exactly. That model also possesses the understanding required to look at that code base and identify a zero-day vulnerability. The capacity to build is the capacity to break.
The report highlights the intense regulatory and legal pressure Anthropic is facing in 2026 because of this exact dynamic. They have been very public about their safety protocols. They operate under a responsible scaling policy, RSP version 3, which is designed to initiate a race to the top in AI safety.
Right. They formalize conditional mitigations and risk assessments.
Uh,
They really want to be seen as the adults in the room.
But the reality on the ground is highly combative. In March 2026, the U.S. government, specifically the Pentagon, hit Anthropic with a supply chain risk designation.
That was a huge deal.
Yeah. While Anthropic challenged it in court, the designation itself is a glaring indicator of how nervous the national security apparatus has become regarding these foundational models. Furthermore, around the exact time Karpathy joined, a judge was reviewing a massive copyright settlement related to the training data Anthropic used.
So they are fighting a multi-front war. They are fighting OpenAI for market share. They are fighting the Pentagon over supply chain optics. And they are fighting copyright lawyers over data ingestion.
It's a lot.
But the cyber risk aspect is the one that really caught my attention because of a specific initiative the report mentions. Project Glasswing.
Oh, Project Glasswing. Let's talk about that.
Project Glasswing is the perfect encapsulation of the dual-use dilemma. During the launch of Glasswing, Anthropic essentially admitted the terrifying scale of their own progress. They announced that an unreleased model, internally dubbed the Mythos Preview, surpasses all but the most highly skilled human experts at cyber exploitation and vulnerability discovery.
Wait, let's step back. Let me make sure I'm fully grasping the weight of that.
What?
They have built an AI that can find and exploit vulnerabilities in software systems faster and more effectively than almost any human hacker on the planet.
That is what the data implies, yes. When you scale pre-training and you push heavily into verifiable domains like coding, cyber capabilities naturally emerge as a byproduct. You cannot isolate them.
This presents a massive, almost paradoxical tension. I mean, on one hand, Anthropic is publishing lengthy transparency reports. They're actively lobbying regulators saying, look, we do model spec mid-training, we filter our pre-training data, we are the safe, responsible lab.
Right, that's their whole brand.
But simultaneously, they are publicly admitting they possess an unreleased model that is superhuman at cyber exploitation. If Anthropic is actively telling the Pentagon, we are safe, while simultaneously building this, isn't hiring an elite scaling expert going to make external watchdogs incredibly nervous? How do they balance that?
It is the defining tightrope walk of the frontier AI industry. Anthropic's core philosophical argument is that you must build the capability in order to understand how to defend against it.
Like a white hat hacker.
Exactly. You cannot build defensive infrastructure against a theoretical threat. Their safety philosophy, which Karpathy is now integral to, relies heavily on shaping those capabilities deeply within the pre-training and mid-training pipelines.
So the logic is we have to build the model that knows how to find the vulnerability, but we use synthetic data in mid-training to ensure the model is fundamentally aligned to patch the vulnerability rather than exploit it maliciously.
Precisely. They believe that by having the absolute best applied researchers working on the base models, they can bake the safeguards directly into the model's neural weights rather than relying on brittle post-training filters that can be easily jailbroken.
It's a massive gamble. They are asking regulators and the public to trust that their mid-training methodology is robust enough to contain superhuman hacking capabilities.
And that is a huge ask.
Which brings us to the ultimate question. How will history judge this moment? When we look back at May 19th, 2026, will it be seen as the day Anthropic cemented its dominance and ushered in a safe agentic future? Or will it be seen as a cautionary tale of hubris?
That's the million-dollar question.
The final section of our report lays out the specific scenarios, risks, and a watch list for the next year. How will we know if this hire was a historic success or a cautionary tale?
Well, the intelligence report is very pragmatic about the risks. The first major risk they identify is over-personalization.
What does that mean in this context?
It's a classic trap in tech analysis, applying the great man theory of history to industrial-scale engineering.
Oh, right. It's easy to do. We just spent an hour talking about Karpathy's unique genius and his historical trajectory. It's tempting to view him as a silver bullet.
He is undeniably brilliant, but frontier model development is no longer a one-man show. Anthropic is operating with billions of dollars in financing, tens of billions in compute, and massive, highly specialized teams.
He's just one guy at the end of the day.
Exactly. An elite hire can absolutely bend the curve of innovation, but he cannot magically substitute for clean data sets, robust hardware infrastructure, or institutional discipline. If the market or investors believe that Karpathy's presence guarantees victory, regardless of the underlying execution, they are drastically overreacting to the signal.
That ties directly into the second risk, expectation inflation. Anthropic has painted a phenomenal vision of the future. They are promising unparalleled safety, massive scale, and total developer dominance with Software 3.0. But the reality is that they still have unresolved, messy governance issues. The Pentagon clash isn't fully resolved, the copyright lawsuits are ongoing.
And their own RSP version 3 acknowledges a hard truth. Achieving some of their advanced safety goals unilaterally might actually be impossible in a highly competitive market.
They might need everyone on board.
Right. They might need industry-wide coordination, which is currently non-existent.
Yeah.
The hype surrounding Karpathy might inflate expectations to a point where Anthropic is expected to flawlessly deliver hyper-fast capability leaps while simultaneously maintaining perfectly clean governance. That is an almost impossible standard to meet.
But the third risk identified in the report is the one that I find the most intellectually fascinating. They call it path dependency.
Path dependency.
And it stems directly from this massive focus on coding and verifiability that we talked about earlier.
Path dependency is the danger of over-indexing on a specific architectural strategy. We discussed how Karpathy's worldview and Anthropic's commercial strategy strongly privileges verifiable high economic value domains like software engineering. The risk is that the models become incredibly specialized.
Right. They become savants. If you focus all of your 5 gigawatts of compute and all of your synthetic data generation on making the model an eponymous coding god, it might lose its general utility.
Exactly.
It might lack grounded, common-sense reasoning in domains that aren't perfectly verifiable.
Worse than that, over-indexing creates safety blind spots. If all your training attention is focused on agentic coding environments and cyber threat analysis, you might inadvertently underinvest in monitoring other dangerous capabilities that don't fit neatly into the Software 3.0 paradigm.
So it's amazing at coding, but terrible at predicting real-world consequences in other areas.
Right. The model becomes a hyper-optimized tool for one massive task, but potentially fragile or unpredictable outside of that specific workflow.
So for the listener who is trying to cut through the noise, who wants to know if this grand experiment is actually working, what is the actionable intelligence here? What should we be watching over the next 6 to 12 months?
The report provides a very clear, concrete watch list. First, monitor the pace of pre-training efficiency.
How do we measure that from the outside?
If Anthropic begins releasing models that demonstrate massive capability leaps, but the public disclosures indicate they cost significantly less compute to train than expected, that is the unmistakable signature of AI-accelerated research. It means Karpathy's team successfully built the Claude-improving Claude loop.
It means the recursive acceleration is real.
Exactly. Second, watch the evolution of Claude Code and their agentic products. Do we see a sudden discontinuous leap in long-horizon performance? Can these agents handle vastly more complex software engineering tasks autonomously without requiring constant human steering?
Right, if you can just leave it running overnight and it builds a whole app.
Exactly. Third, track the research output. Look for new foundational papers on synthetic data generation or mid-training methodologies that will indicate that Karpathy's specific operational expertise is bearing fruit.
And the final indicator the report suggests is watching Anthropic's overall corporate identity. They suggest looking for a shift from being a standard model provider with a strong safety brand to what they call an integrated intelligence stack.
That is the ultimate endgame for Anthropic. They don't just want to sell API access, they want to provide the entire ecosystem.
What does that ecosystem look like?
It's the frontier-based models, the locally trusted agents running directly on your machine, the enterprise deployment infrastructure to scale those agents, the fundamental cybersecurity primitives to protect the whole system, and the formal governance artifacts required to satisfy national security regulators.
So you shouldn't just look for a shiny new model announcement. Look at the developer platforms, the rate limits, the enterprise adoption. That's where Karpathy's DNA will show up first.
Yes.
Are rate limits being eased because the underlying training and inference got drastically more efficient? Look at the velocity of enterprise adoption. It won't be a headline. It will be legible in the fundamental efficiency of the tools developers are using every single day.
If he succeeds in optimizing the engine room, The strategic result is a durable, compounding operational capability, not just a fleeting public relations victory.
We have covered an immense amount of ground today. We started with a single employment announcement on a Tuesday in May, and we've seen how one hire is the focal point of the AI industry's evolution.
It really pulls it all together.
It brings together the absolute capability bottleneck of pre-training, the multi-cloud compute war involving hundreds of billions of dollars and multiple gigawatts of power, the severe dual-use cyber risks, and the philosophical push towards Software 3.0, where AI agents become autonomous creators.
It is the total convergence of elite talent, massive capital, hyperscale infrastructure, and an urgent, relentless race to build systems that are capable of building themselves.
But before we wrap up this deep dive, there is a final concept hidden within this idea of recursive acceleration that we haven't fully explored, and I think it's worth leaving the listener with something to mull over.
Yeah, there's a deeply provocative question that arises naturally if Karpathy's team in Anthropic actually succeeds in their mandate.
What's the question?
Historically, throughout the entire history of human technological progress, we have always viewed human intelligence and human ingenuity as the primary limiting factor. We are the creators, limited by our own biological brain power, our need for sleep, and the hours in a day.
Right. The pace of innovation has always been constrained by the speed of the human mind.
But if this meta-research loop truly takes off, if they successfully make Claude hyper-efficient at conducting its own pre-training research, analyzing its own architectural flaws, and generating its own synthetic data to align itself,
Yeah.
at what point in the near future does human engineering stop being the catalyst for AI development and instead become the slowest bottleneck in the self-improving loop?
Wow. We currently think of humans as the limiting factor in designing AI. But when does the system realize it can iterate faster without us?
Exactly. When does the human operator shift from being the master toolmaker to being the friction that slows the factory down?
That is a thought that will definitely stick with you long after you close your laptop today. Thank you so much for joining us on this deep dive. Keep your eyes on the frontier, watch the compute, and we will see you next time.